Hey fabulous fifth graders. So let's look at dot plots today. I have one here for you that uses fractions, and then in a minute we'll look together at one that uses decimals. We use dot plots to be able to show how often some number occurred in a set of data. And that's similar to what we talked about yesterday with stem and leaf plots. But remember, stem and leaf plots helped us to see how often something occurred in a range, like how often students scored in the 70s on a test. So this helps us to see how often a specific number occurred. In this dot plot, we're looking at shoe sizes in Miss Cooper's class. And you can see that we're talking about shoe sizes from 6.5 up to a 10.5. And for each one of these dots, one person had that shoe size. So one important thing to remember on a dot plot is if you don't see a key, then the dot represents the number 1, represents one occurrence. If you do see a key for the dot plot, then obviously you have to make sure you're using that key to determine how many times something happened. So let's look at this dot plot and see what we can figure out. So we've already talked about 6.5 to 10.5 being the range of this dot plot. Sizes fell somewhere in that range. And you can see that we have 6.5, 7.5, 8.5, 9.5, and 10.5 numbered, but there are dots in between those in several places. So you might be looking at it wondering, I don't know what this represents. What is our scale counting by? Well, I can see that if I have 6.5 and 7.5 and one something between them, that one something is what I'm trying to figure out what it represents. And in this case, that would represent whatever's exactly between 6.5 and 7.5. And right between 6.5 and 7.5 would be the number 7. So if we try that out, it would be 6.5, 7, 7.5, 8, 8.5, 9, 9.5, 10, 10.5. And that would make sense because that's the way shoes are sized, either a whole number or half sizes, 6.5, 7.5, etc. So we know that these are whole numbers, 7, 8, 9, and 10. So now we can also look to see what information could we figure out from this graph. I might ask you, what was the most common shoe size in Miss Cooper's class? And you would be able to look at this and see that 8 is the most common shoe size because there are 5 dots here, and there are no other sizes that had 5 dots. So this would be the most common or the most popular. What happened the most would be size 8. I could ask you the least common, and you can see that both 6.5 and 10.5 have one person that had that shoe size, so they would be the least common. I could ask you things like how many students were in the class, and you would be able to count up the number of dots to know how many people there were that we checked their shoe size. So that's one way to use a dot plot. And now we're going to create one together that uses decimals. So here's our framework for our dot plot, and we're going to be using some data about the cost of carnival games. I have our data here, and you can see the prices are listed here for each of these activities. And I have our line, but I've got nothing else on it yet. So we need to talk about how do we create a dot plot. Well, first of all, our numbers are going to go in order from least to greatest, just the same way we talked about with stem and leaf plots yesterday, the lowest to the highest. And I can look at my prices and see that my lowest price is $1, and looking at it, I see the highest price is $4. So I know I need to start with $1 and I can end with $4. Could we have prices that were less than $1? We could, but we don't. And we could have things that cost more than $4. But in this data, that's all we need to show. So that's what our beginning and ending numbers will be. Then we need to decide, how are we going to break those numbers up? What's going to happen between $1 and $4? We know we should probably have $2 and $3, but we also have prices that are in between those. We have $1.50, $1.25, $1.75. So we need to be able to record how many games were at each price, but we also don't want to have so much information on here across our scale that it's sloppy. So like the shoe size dot plot, we're going to skip some numbers and be able to figure out what number is in between. So we're going to start with $1 and we're going to count by 50 cents. $1, $1.50, $2, $2.50, $3, $3.50, and $4. And we're going to allow our key to equal one dot is one game. So that means I don't have to include a key, because if a dot equals 1, I don't need a key. If you see a dot plot with no key, again, the dot equals 1. If there's no key, the dot equals 1. So we're just going to go down our list and put dots for each one. The balloon pop cost $1. It gets 1 dot. Beanbag throw, $1. Cakewalk, $1.50. Dart throw, $1.25. So I need us to think about money. If I'm counting money and I'm thinking in terms of $1.25, here's $1.75, $1.75, $1.25. I'm thinking in quarters. So I would have $1, $1.25, $1.50, $1.75, $2, $2.25, and I could keep going. So for $1.25, it would be halfway between $1 and $1.50. So for the dart throw, $1.25, we would put a dot here. The dunk tank is $3, so that would need a dot. Face painting is $1.75. So if this was $1, $1.25, $1.50, this would be $1.75, then $2. So this is $1.75 for face painting, gets 1 dot. Fastest pitch, $1.50 gets a dot. Football toss is $1.75. Again, that's right here. Gaga ball, $2. Horse ride is $4. Petting zoo is $3. Pie toss is $1.50. Ring toss is $1.25. Sack race is $1.50. And the three-legged race is $1.25. So here we have our data represented on a dot plot. And there are lots of questions that I could ask about this. I could ask, what's the highest price that we charge for any of the games? And the highest price would be $4. I could also ask, what's the lowest price? And that would be $1. I could ask, how many games cost less than $2? Well, if I'm asking you less than $2, can I include $2? I can't, because $2 is not less than $2, it's equal to it. So I would have to include everything less than $2. So we would have this many games that cost less than $2. I could ask you how many games cost $2 or more. So then I would include $2 and everything that's more than that. I could ask you, if I wanted to play every game one time, how much money would I need? And you would have to take the time to add up each of these, $1 for this, $1 for this, $1.25, $1.25, $1.25. So each dot represents a game that costs that amount, and you could total the whole thing up using repeated addition. Or you could say there are 4 games that cost $1.50, so 4 times $1.50 would let me play these games. 3 times $1.25, 2 times $1, 2 times $1.75, and then total it up that way. I could ask you, how many games are at our carnival? And you could count up the dots to tell me how many games are at the carnival. So using a dot plot, we can answer lots of questions about this data, and yet it's in a simple, easy, quick way to read.